This is an example for using the 9211A sampling oscilloscope to test a high-speed serial data stream. This signal has been applied to channel 1 of the instrument and is actually an STM4 signal which has a clock rate of 622 MHz. So I'm now going to select the display menu, and we can see we have it in dots mode, so we can see dots here. In this case, vectors cannot be used because it is serial random data, so the data may be high or low, but we could use the variable color graded display. So here we can see color grading, which shows how often the samples at any particular point. So we can see here a rising edge with some blue samples on, which means they're not there so often as at the top and bottom of the waveform. So it's possible to see more information about the acquired waveform using the color grading display. So I'm now going to go ahead and perform a mask test on this particular sample signal. So I'm going to select the mask test, and I'm going to select standard masks. So these are all the masks that are available in the firmware of the instrument. So we've got PCI Express, Ethernet masks, InfiniBand, Fiber Channel, Ethernet, Rapid I/O, and some Fiber Channel. So I'm going to select here Sonnet, and this is actually an STM4 signal, I say with a clock of 622 MHz. So I'm going to select STM4, and I've also selected Align, and this will try and align the mask with the acquired waveform. I'll say OK, and I'm going to clear the display. So here we can see what it's attempted to do is to find the crossing point and position the mask at that point. As we can see, this particular waveform has got quite a slow rising edge, and in fact is going into the mask. So we could perform a mask test at this point and see what it would see where the waveform crosses into the mask. So I'm going to select from back the run utility action, and I'm going to look for the waveforms which violate the mask, and here I'm going to select 800 waveforms, and back, and I'm going to turn on the test. So now we can see here the red tells us that the waveform is violating the mask at this point, and here we can see the total number of acquired waveforms. I selected 800 and it reached that, and we've seen the total number of points inside that mask. Now it would be possible and would be quite valid to actually move that waveform in time and clear the display, and now we are getting a valid pass. So this signal could pass the STM4 standard mask at that point. So let's just check my waveforms, 800, and now if I turn on that test, we're not getting any failed waveforms against that mask test.